This video is about the chi-square test for independence. A chi-square test for independence is a hypothesis test that we perform if our objective is to test for the relationship or the association between two qualitative or categorical variables. That's why it's called a test for independence, because we are trying to see if the two categorical or qualitative variables are independent or not of each other. If we are testing for the association or relationship between two categorical variables, we need to have a contingency table. And a contingency table is a table that contains two variables, where one variable is in the rows and the other variable is in the columns. And the numbers inside the table are the frequencies. Important values from this contingency table are the individual frequencies for every intersection, the row totals, and the column totals. Now, for the chi-square test for independence, we will consider this example of the brokerage firm case from the textbook. So in this case, a brokerage firm sells several kinds of products such as a stock fund, a bond fund, and a tax-deferred annuity. And the case wishes to know if the satisfaction of the customers depends or is related to the type of the product purchased. So they want to know, for example, if purchasing a bond makes the customers more satisfied compared to other types of funds. So that's what they are trying to figure out in this particular case. Now, in order to answer this, they got a sample of 100 clients and they asked for the type of fund that they purchased and their customer satisfaction, and they have summarized the responses of these 100 participants into this contingency table. So we have on this side the different types of products that can be purchased, and on this side we have the three levels of satisfaction. So we have here the intersections of the two factors. So 15 here means that out of the 100 participants, 15 of them purchased a bond fund and had a high satisfaction rating. Whereas the 2 here means that out of the 100 participants, 2 purchased a stock fund and had a low satisfaction rating. Now, the chi-square test for independence uses the following null and alternative hypotheses. So the null hypothesis of the chi-square test for independence states that the two classifications are statistically independent, and the alternative hypothesis states that the two classifications are statistically dependent, or in other words, that the two factors or the two variables are related or associated to each other. Now, the test statistic for this hypothesis test is still a chi-square test statistic, which is computed using this formula. And this is very similar to the formula of the chi-square goodness of fit test for multinomial probabilities. So we get the summation for all the intersections that are being compared, and for each intersection, we will compute for this value. So this is the observed frequency for the intersection. This is the expected frequency for that intersection. Get the difference and get the square and divide that by the same expected frequency for that particular intersection. And again, we do this for all the intersections and get the sum, and that is your test statistic. Now, to compute for the expected frequency for every intersection, we have this formula. So that's the total of the row times the column of the total of the column, and divide that product by the total sample size. Or in other words, that's the total sample size. We multiply that to the proportion of the sample that is part of that particular category for one variable, and also the proportion of the sample that is part of the other category that we are looking at. So again, any of these two formulas, these two are the same, but this formula gives us the expected frequency, which we will use to compute for the test statistic. And once you have the test statistic, we compare that to a critical value. And again, this is based on the chi-square table with a subscript of alpha. So we look for a chi-square score with an with an area of alpha to its right, and based on degrees of freedom of r minus 1 times c minus 1, where r pertains to the number of categories for the first categorical variable, and c pertains to the number of categories for the second categorical variable. So, again, just like the chi-square goodness of fit test for multinomial probabilities, the chi-square score is obtained from the chi-square table. Now, the chi-square test for independence has the following assumptions. So, just like the first chi-square goodness of fit test, the assumption of this test is that the sample size should be large enough. And the sample size can be said to be large if all the expected frequencies are at least 5, or if all of these three other conditions are met. First, that all expected frequencies are at least 1, that the number of cells or the number of intersections is at least 5, and finally, that the average of all expected frequencies is at least 5. Now, for the brokerage firm case, we were given this contingency table earlier. And from here, we can compute for the expected frequencies of the different intersections. And what we have here are the expected frequencies for all of those intersections. So again, for the first one, for bond and high, the formula for the expected frequency is row total times column total over the overall total. So for the intersection of bond and high, the expected frequency is 30 times 40 over 100, and that gives us 12. And then we do that same procedure for all the other intersections. So for bond and medium, that's 30 times 40 over 100, and that's also equal to 12. And for bond and low, that's 30 times 20 over 100, which is equal to 6. So again, we do that for all the intersections, and these are the expected frequencies that we will compare to these observed frequencies. Now, if you look at these expected frequencies, all of them are at least 5, which means that the sample size can be considered large enough, and therefore we can proceed with the interpretation of the results of the chi-square test for independence. Now, to compute for the test statistic, we will use this formula that was shown earlier. So again, we compute for this for every intersection. So for the first intersection, that's for bond and high. That's 15 minus 12, and the difference between the two is squared. And divide that by this same frequency of 12. And that's what we are seeing here. And then for the second intersection, that's bond and medium. So again, that's 12 minus 12, quantity is squared, over 12. And that's what we are seeing here. So again, we do that for all the 9 intersections and get the sum. And you will get a test statistic of 46.4375. Now, this test statistic will be compared to a critical value, which is obtained from the chi-square table with degrees of freedom of r minus 1 times c minus 1. So in this example, we have 3 categories for both variables. So degrees of freedom should be 3 minus 1 times 3 minus 1, which is equal to 4. And therefore, if we look for a critical value for an alpha of 5%, then the appropriate critical value would be 9.48773. And since the test statistic is clearly greater than that critical value, then at an alpha of 5%, we can reject the null hypothesis. And therefore, we have strong evidence, we are 95% confident that the two variables, the type of fund purchased and the satisfaction rating, are associated or are dependent or are related to each other. So through that chi-square test for independence, we are able to see that these two variables are associated with each other. That when you change the type of the fund that you purchase, we expect that there will also be a change in your satisfaction rating. Now, if this test is performed using SPSS, the results would look like this. And there is only one row that is relevant here, and that's this first row. So this first row here shows us the results of the chi-square test for independence. So this one is the rounded off value of the same test statistic that we got earlier. So that's 46.438. And results in SPSS gives us the p-value, and this is less than 0.001, which means that even at a lower value of alpha, which is 0.001, we can still reject the null hypothesis. And therefore, we have extremely strong evidence to support the claim that there is an association between the type of fund purchased and the satisfaction rating. And the results of SPSS also shows us that the sample size is considered large because all the expected frequencies are greater than 5. Okay, no intersection, 0 cells have expected frequencies that are less than 5, which means that these results can be interpreted, or these chi-square test for independence results are valid and can be interpreted because the sample size is considered large enough.